And here we go. We have liftoff. Propulsion continues to be normal.
RCPA chamber pressure looks good.
Doubling up. Roger, planet.
Water towers, fly! Yes!
Tango down to nominal.
Flight downside FTE off. Bring in FTE off. Off. It's orange!
R45! Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, Signal.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. Keep that. Sure. We don't need any more of these.
All right, folks, it's Sunday, June 23rd. Let me know if you can hear me and see me real quick. John Galloway with NSF here with a very special event. It's Intrepid Museum's Astro Live. We're virtual today. Y'all know how these go, but give me some 5x5s over there in the chat so that we know that all of the lights are blinking in the appropriate order so we can go ahead and begin the event. Now, today's event will also feature live ASL interpretation. You can see it right down here. Our fantastic interpreters will be interpreting what we are saying live to increase the accessibility of the show. One of the things we try to do to help out here with Intrepid Museum. What I need to remember to do is speak more slowly so that they can keep up with me. But they always do a fantastic job. Put some love over in the chat for our fantastic interpreters. I see a bunch of 5x5s over there. Big M, Kelly, Gary, Steve Myers, Vintage Gal, everybody who's joined us today. We have a fantastic set of guests. It looks like everything's working correctly here. So let's go ahead and get started. I am first going to introduce a person you've seen before on the streams here, especially with Intrepid Museum. Mr. Mike Massimino is joining us, and he's going to be introducing our second order special guest, our extra special guest. This is going to be fantastic conversations today, y'all. So let's go ahead and get Mike over here. Mike, how are you doing today?
I'm doing okay, man. It's good to see you.
All
Thanks
right.
for having me on.
You ready to take control of the show and introduce Fred here?
I'll do my best. I want to get right to him. This is a legend that we're speaking to today, folks. For me, it's quite a thrill. Fred Haise, one of my boyhood heroes, amazing career, NASA astronaut engineer, fighter pilot, U.S. Marine, also in the Air Force, an Air Force test pilot, but known maybe best for what he did on Apollo 13 as the command module pilot on that mission, very famous mission. Of course, book was written by Jim Lovell and Jeffrey Kluger and made into a very popular movie that also inspired me. Fred, I don't know if I ever told you this, but when I was rejected my third time from the astronaut program, it was in 1995, and went to see Apollo 13. And I remember sitting there and watching you being portrayed in the movie, of course, very prominently, along with Jim Lovell and Ken Mattingly, who was on the ground, and Jack Swigert and Gene Kranz, and it just made me want it even more. I wanted to be a part of that team, not even so much flying in space, but wanting to be the part of the team that you were a part of, and working on mission control with other astronauts. And so that was a very inspiring time for me. In your life, your career was very inspiring to me, and then to get a chance to meet you and know you a bit down in Houston, and to get to do this with you today, I'm really, really thrilled. So as your introduction to Fred Haise, and why don't we get right to it, Fred? Well, before I forget, I do want to tell everybody about your book. We did a book event. It was about a year and a half ago now. The book came out about a year and a half ago, Fred. So
about that, yeah.
Yeah, but a great book. I really enjoyed reading it, and just a wonderful book if anyone wants to learn more about, not just about the Apollo missions, but about the amazing life of Fred Haise. It goes into his background, where he grew up, and how he grew up, and how he got to where he was, and what he's up to since. So a wonderful book, and also a website which has so much information, because we're just going to scratch the surface on on Fred's experiences today. But fredhaise.space. I get that right, Fred?
That's it. Space is a
Fred
new
Haise dot
domain.
space.
New
That's the
domain
website
is
to go to.
created. Yeah.
So, Fred, why don't we go right to it? You know, the Apollo program was, I think, maybe the most amazing engineering program ever. And I say this, my son is currently a grad student. He's up at MIT, and he took a course that is taught on Apollo. They have a whole course, a graduate engineering course on the Apollo program. It talks about all the amazing accomplishments that all the talented collected and what they were able to do. Is just maybe such a great accomplishment. And you were a part of it. You were right there on the tip of it, right on the tip of the sword, getting ready to go. And why don't you, can you bring us back to that time? Warm us up a little bit. What it was like to be there at that time. I know you were the backup for Apollo 8 and also a backup for Apollo 11. Why don't we start there and tell us what was that like going to the moon, backing up those crews, but being a part of those missions before Apollo 13?
Well, Apollo was a very unique time and obviously a very unique program. It was triggered really with a pronouncement made by President John F. Kennedy that said we would go to the moon at a speech he gave at Rice University here in Houston, where I live. And it was, to me, it was, at the time, I was a test pilot for NASA at Flight Research Center at Edwards Air Force Base. And I thought it was pretty remarkable. I didn't know too much, except I knew NASA didn't have much more than view graphs about how to go to the moon at the time. So it was a program, though, that with the president's pronouncement was followed with the backing, total backing from a budgetary sense of Congress. A very unique program in that sense. So I feel blessed to have been able to apply and join the program. Unfortunately, not after we had a tragedy on the launch pad, and I was a little worried about how this thing really get underway, but it did not stop. I mean, it was just as much impetus and extreme schedule pressure to meet the goal the president had set on many people across the program, not just NASA, but the contractors, subcontractors, piece parts manufacturers, to meet schedules. Hardship on families, long hours people worked. So I feel blessed to have been a part of that program with obviously a great adventure of achieving and building spacecraft that could get us to the moon and back. No, I was lucky to get assigned. I was really, as it turned out, calendar-wise, I was first crew of my group to get assigned to a mission. It turned out Ed Mitchell had been assigned actually earlier to as a backup, and which would have put him flying Apollo 13. And they made the very dramatic and it's really a challenging change, NASA, when they switched Apollo 9, Apollo 8, which would originally be Earth orbital mission. They switched it to be the first time to go to the moon, and Apollo 9 moved back, which mission later, which now moved Ed to fly 14, and I got to fly 13, being back up on 11. So I ended up being the first to fly, but unfortunately Ed won the contest. We were competitors. We worked together over a year at Grumman testing limbs. He won because he got to land and I did not. But at any rate, like I said, it was I just feel blessed to have been a part of that program.
You mentioned a couple things there. One was you mentioned what I think you called it the accident on the launch pad. Of course, you're talking about the Apollo 1 fire,
right? Yeah,
where we lost Gus Grissom and Ed White and Roger Chaffee, and I know it was obviously crushing to you guys, but you kept going. And it gave you, I mean, I don't remember that, of course. I was too little to remember that, but I've learned so much about it. But,
yeah.
but it was one of you guys. It was a setback, but you guys didn't let it stop you.
No, it did. It put a lot of heat on. When I worked at that time I mentioned for a year with Ed Mitchell, we worked at Grumman testing the lunar modules, getting them ready to ship to Florida to go fly. I just can't imagine the pressure on the same equivalent, the same people at North American Aviation at the time who was building the capsule and the service module, because of the rework and redesign work they had to also swallow. Because at Grumman in 1967, when I was on that work, the test operations, which I was involved with the vehicles, was scheduled 24 hours a day, 7 days a week. That whole year, 1967, we only shut down one day, Christmas Day. So that was the kind of schedule going on. And I'm saying I can't imagine what it was like out at North American, where they had on top of them that added work of the redesign and some reconstruction on the Block 2 vehicle to still keep in line with the schedule.
I don't know of any other engineering project that was like that. I mean, maybe, I don't know, maybe during the war we had something like that going, but do you know of any other project like that? I don't think it was.
I would say that, yeah, the one I would say was the Manhattan Project.
All right.
The work to develop the first atomic bomb.
Yeah.
I think they were under the gun in much the same way as far as the schedule pressure.
Yeah, that's the way it seems. That's what a national goal it was, though. It was up there,
right?
Just like the Manhattan Project. The other thing you mentioned, let me ask you this. So you mentioned about like Apollo 8 was turned into from an orbital mission to a moon mission. Did that also affect down the line? You said so it affected you, and did it also affect Apollo 11 to be the landing? If it didn't happen that way with Apollo 8?
Well, it enhanced the ability to make it within a decade. In fact, when 11 landed, we only had one more opportunity with Apollo 12. Possibly 13 could have been squeezed in, but really, if 11 had not made it, 12 was the last chance to make it within a decade. So no, that was it was close.
It was. All right, so Apollo, going with Apollo 8, again, you were the backup for that. And when you were the backup for that, were you also with the same guys that you flew with on 13? Were you guys backup for? Well, Jim Lovell, I guess, was on 8, right? So,
right. Yeah. No, the backup crew I was first on with on Apollo 8 backup was Neil Armstrong and Buzz Aldrin. So we were the backup crew for Apollo 8.
Okay.
And then, of course, they cycled to 11 and got to fly. And Mike Collins, who had been taken offline, that gave me a chance for that position. Unfortunately, he got well. He overcame his medical problem, and he got moved back in because he had seniority over me. I was in a group behind Mike.
Yep.
And so I had to fly a second backup with Jim Lovell and Ken Mattingly on 11.
So you got trained to be the command module pilot on 11 then.
No, I was a lunar module pilot.
Okay, so you would have been. All right, so Mike became the command module pilot,
and
Buzz moved over to the lunar module pilot.
Right, exactly.
Okay.
Yeah.
All right. Well, that would have been something.
Yeah.
But okay, so for 11, when they were training for 11, and you were the backup for 11, were you assigned as? Was 13 also were you going to be prime on 13 at that time?
No, we would have flown 14. Normally the cycle was 3 missions.
Okay.
If you had 3 to 11, we would have flown 14. Bill Anders actually was the command module pilot for about 4 months.
Okay.
And he was command module pilot when we started training, but he realized he would be too long a turnaround. And he he wanted to land on the moon, and he figured the turnaround to get back through another backup assignment and get to land on the moon would be too long. So he left the program at that time, and Ken Mattingly filled in to replace him. No, the hardest training cycle I had was Apollo 8. You have to realize I was a real expert on the LEM. I knew even almost to the point of what pins were and what 48 pin connector, what functions they were with all the troubleshooting and testing and problems we had over that year. And here I went to a mission that didn't have a LEM. Apollo 8 didn't have a lunar module, and I had never been in the command module. I'd never been in one.
Oh.
So I was starting from scratch, learning a new spacecraft to get ready to fly that, be prepared to fly the mission as the lunar module pilot without a LEM.
Yeah.
So that was a hard training cycle because when they made it, and also when they made the mission change from Earth orbitals, it would be 4,000-mile apogee, a rendezvous kind of mission, to go to the moon. There was a lot of change, obviously, total change in flight plan, mission rules, etc. Plus unpack the training I had. So it was really the toughest training cycle, tightest, because we lost about the first 2 months of the 6-month training cycle, training for the wrong mission. And so that was the toughest one I had of all the cycles I had.
Yeah. Yeah, what you're describing is a lot of hard work. You know, a lot of sacrifice, tough on the family, working around the clock for everybody. And that's kind of what the astronaut job is. I think it was heightened when you guys were trying, because you had that deadline, you're trying to get there by the end of the year. What was the feeling, though, as far as like did you have much of the idea of the historical perspective of what was going on? Sort of the little boy dream of getting a chance to be a part of that Apollo 8 and Apollo 11, two very historic missions. The first time we left the planet, really, to go to another place and in the land. Were you just so wrapped up in the technical part of it that it was hard to have a sense of what was going on around the perception of it and the historic significance?
No, I of course realized that significantly. The first crew, as it happened, went to the moon, and the first crew that landed would be historical. I mean, we had landed a couple of craft on the moon. We had orbiters around the moon that got some of the good scenes that were used in picking out the landing sites that were chosen. But no, I didn't dwell on that. To me, it was just preparing to go do a great adventure.
Yeah.
I almost did not apply to be an astronaut. I was having fun at Edwards Air Force Base testing airplanes. And I sometimes I did show once, I pulled 2 pages out of my flight log, which covered 1 month. At an event, I went back there to talk about the old days. And that 1 month, I had flown 9 different kinds of aircraft. I'd flown in 3 different test programs. And had flown support missions for the X-15 that was ongoing. That unfortunately I never got to fly, and that's why I realized I wasn't going to get to fly the X-15. That's what I was really hoping to do. Neil came back. Neil was a NASA test pilot ahead of me about 3 years. We both started at Lewis Research Center in Cleveland, NASA. I actually joined NASA just in the first year they became NASA as a test pilot. Then I cycled to Edwards after Neil had gone there and left to go in the astronaut program, and I went to Edwards behind him. He did get to fly the X-15. Came back and visited one time, and Don Malik and I, another research pilot there, got it cornered Neil and said, "What's it like being an astronaut, Neil?" He said, "Well, you sit in a lot of meetings." He said, "You sit in a simulator a lot of time." He said, "There's not much good flying." So he was describing what our experiences had been at Edwards, flying, testing aircraft. But at the time, I had to make a decision to apply in 1965, near the end of the year, to make up my mind whether it's going to apply or not for that group. I realized in the office it went by seniority as to how you would move up and get to fly the X-15. And there was 3 ahead of me at the time. Now, Bruce Peterson took him out of line. He crashed the lifting body and lost an eye. It was a footnote to one of the TV shows in Hollywood, in fact.
The $6 million man?
I only had 2 ahead of me, but I realized that probably before I got the chance, the program would be over. So I decided the only way I was going to get to go higher and faster was to join the astronaut office, which for me was just another transfer. I'd been a NASA employee at that time over 7 years. So I just packed up and moved to Johnson Space Center in 1966.
And so how would you compare the flight? And the Neil, of course, that you're talking about, maybe is Neil Armstrong, the first person to walk on the moon.
Armstrong, right.
That's Neil we're talking about there. Well, how did you feel about it, Fred? Did you feel like that you were, when you're came to NASA, was it what you expect, or the way Neil described it? Was it less flying? Because you guys were flying that spaceship, right? You were flying the Lunar Module, but how did you feel about it? Was it a big difference for you?
Well, yes, it was obviously the spacecraft we had only had a small computer. Both the LEM and the command module had the same computer as far as memory, about 1/10 of a megabyte. 1/10 of a megabyte, not gigabyte. So it was pretty well limited to do guidance, nav, and control. So everything else you did with the spacecraft was manual. Unlike today's spacecraft, including shuttle, which came along fly-by-wire through a muck system, we had direct 28-volt DC bus wiring to all 16 attitude thrusters. We had direct wiring to all the rocket engines. We could manually stop and start them. So we had full manual capability in those vehicles, which came in handy on the 13 when we had to power down severely and didn't have a computer anymore. For 4 days, we had the computer turned off. So we had to do the mid courses we did coming back. A couple of them we did out the window manually, using our controls to hold attitude while we then manually fired either a decent engine or the LEM in one case, or our attitude thrusters, using them for propulsion. 4 of them aligned in the x-axis, give us a change in our path. But no, there was flying involved, but there was a lot of simulation, which was good simulation training, because our simulators, which I'd never experienced with airplanes, were built so they could impose failures, what we call credible failures. In fact, over 500 were available to test us in the command module simulator, and about, I think it was about just 300 roughly in the LEM. And we did simulations, and that's what Neil was talking about, the time and sound simulation Neil Armstrong talked about. We would sit in the simulator. I'd probably had over 2,000 hours before I flew some of the missions. When mission control would be hooked up, they would see exactly what we were seeing on our instrument panel. And of course, they'd see the manifestation of the failures. And a group behind the scenes, led by Honeycutt at the time, worked their best to figure out failures they would put in that would make us look bad. They wanted to test us. They wanted to make us look, they took great glee if we looked bad. Testing not just us, but mission control. Could they work the problem properly? So that went on, and I said, so we felt, and it gave me a lot of confidence, obviously, in watching that same real-time exercise go on, because all missions had some degree of problems to deal with, every one of them. And of course, I witnessed that before I flew. As a backup, I was always in mission control at critical times on Apollo 8 and Apollo 11. And we had problems there to deal with. So I was confident, and that training made me confident, even with the situation we had on Apollo 13. I knew that a great brain trust was at work to try to figure things out.
So there's a lot of stuff here, but let's go with the idea of the simulation and how it helps you in the mission, because I saw some of that, and I remember we never were challenged in flight the way we were challenged in the sim,
right?
But Apollo 13 was like, you didn't simulate. Was that anything you could fall back on? Did you have that test case, or
no? The only workarounds we did that we had done in simulation was the use of manually doing a maneuver, both maneuvering the spacecraft to an attitude and holding it steady, all manually, and firing either the main engine or firing the thrusters, all we call it 4-jet RCS, where all 4 little 100-pounders could be directed to fire simultaneously in one direction for propulsion. And we had done that in training.
Mhm.
So that was the only, call it off-nominal thing we did that we had exercise. No, obviously the lithium cartridge that was pictured in the movie,
Mhm.
the so-called mailbox, that had to be invented in real time by mainly people in Building 7 at Johnson Space Center. Crew systems people had the spacesuit people. They had a LEM environmental system and a chamber. They actually jury rigged the same kind of thing they ended up passing up to us to build, and put it in that chamber, and actually impregnated it with a lot of carbon dioxide and actually tested it real time that way to make sure it would work. Before that, then that fabrication was then passed up with a very detailed procedure to build in flight. So that was all new. A big one that was new that I felt, to me, was personally, I felt the most concerned about and been able to execute. We powered down the mothership, the command module. It's never ever been planned to ever shut down in flight. So there was no procedure to power it up. So people on the ground worked a lot of hours, subsystem guys and both the NASA and contractor, to figure out that procedure, which normally was done with a lot of support equipment on the launch pad, to get us to manually be able to power that craft safely back up. The problem was they did not finish developing the procedure and then having it tested in simulators by other astronauts. I know Al Shepard and Stu Russa and Charlie Duke and John Young spent a lot of time in the simulators testing that activation procedure to redline it in some cases when they found something wrong, before it was sent up to us for Jack Swigert to copy 17 hours before entry. So we were 17 hours before hitting the air. It was the first time we got to look at it. And Jack Swigert and I were going to implement it. Jim was going to stay in the lunar module to maintain attitude and communication, et cetera. And the worse yet, after we got to read it a few times, Jack and I worked our way through it, kind of getting the feel of the flow of the procedure for the system's turn on. We were not allowed to start the activation until 2.5 hours before entry. So we're now approaching 25,000 miles an hour, fixing to hit the air, sitting in a dead spacecraft. When we crawled in, you know, it was dark. We had flashlights. Water was covering the instrument panel. We had to break out towels. Jack got a couple out to wipe off the instrument panel so we could see the meters. And then start the activation. 2.5 hours to go before we're going to hit the air. So that was crucial. I was worried about executing. I was mainly worried had they figured out everything for the warning lights, because I knew from the LEMs, I had tested at a plant, and I tested a lot of LEMs where we turned them on for the first time. And you always get what I call false warning lights if you only have partial of the systems operational. But they had carefully anointed that, and at a very lengthy procedure. That next step we took, is Jack threw a switch or I pushed in something, the light would come on. So it didn't slow us down. Because normally you get a warning light on or a caution light on, you treat it like a CSI investigation. Crime. You stop everything and try to figure out why is that light on. And we weren't slowed down by any of that. So we got the power up done. Jack got a rough, what I call a course platform line. Then you got a couple of star shot sightings. That got us a final line to get adjusted. We did not kick off the LEM. The LEM was still attached. So Jim came back aboard. We got the hatches closed. And we kicked the LEM away pyrotechnically with pressure, excess pressure in the tunnel area, because we couldn't separate the normal way using thrusters on the service module. It was dead, and it had long been separated several hours before. So we were offset and yaw and directionally to make sure it was separated from us at 45 minutes before entry. That's when the lemon, we did it offset and yaw to make sure it wouldn't come back and hit us during entry. the early part of entry. So that was a real tight timeline, getting ready to come back in at the end. And what that was probably the thing that worried me most during the flight, about executing and not screwing up and making an error.
You guys at this point, this is remarkable, Fred. Thank you for the detail, and this is amazing. And you had to do this with just a little bit. You're all right. So you can't rush, right? You've got to go through everything. But you guys were up for a while. I'm thinking you probably were lacking some sleep as well. Is this a true statement?
Yeah, we had the vehicle got very environmentally got very cold. I put on 3 sets of underwear. I had one on, obviously, and I had 2 spares, so I had 3 sets of underwear on. But we didn't have a jacket or anything, and the garments we were wearing were from the fire on the launch pad. They were coated with material that made them assume literally the air temperature. So we were very cold, and I also had, by this time, a day and a half out, I got a urinary tract infection. So I had chills and fever. But what helps you at the time I was just talking about, the power up, is I had a little adrenaline flow going. And when you're excited and you got a lot of adrenaline, it makes you very alert. So I was, it didn't inhibit what I had to do or my mental alertness to handle if things went wrong.
And yeah, none of this stuff, even you mentioned about the LEM, of jettisoning the LEM at the end, and Jim Lovell's inside of it. Did you even have that test case at all coming back with the LEM? Because the LEM was going to be left on the moon, right? So was that?
No, that was in a normal mission. Yes, the normal mission, when they came back and rendezvoused.
Okay.
It would normally be separated and switches set up so that the mission control could, when they chose, fire the decent engine, and they had already loaded in the maneuver program what was needed to deorbit it, and sort of planned in the right spot on the moon to create a simulated meteorite impact, because all the landings, one of the things they put out each time was a seismometer that could record the shock impact of a meteor hitting, or in this case the LEM hitting, and collect subsurface data around those sites where the seismometers could read record what had happened when the LEM crashed. But no, we held on. LEM was our home for 4 days. Yeah, so we couldn't do that, and had to hold on to it till, as I said, to 45 minutes before entry.
But you had never simulated anything like that, I imagine.
No.
Out of all those thousands of hours of they just, the training team would test you and the mission control team, right? It's a joint test when you go through those things. All those thousands of hours. This was a completely new case in many ways, right?
Now, obviously, the procedure had been thoroughly checked out on the ground. As I said, astronauts were in simulators that were running 24 hours a day and available, that they went in and tested the procedures before they were passed up to us.
Yeah. Did it feel like a sim? I mean, because I think sometimes I get, there's things that we had little things happen, that we had to run. We had a leak in one of our spacesuits where we had to pull a guy out, and it was a new procedure. We were trying to, we had to pull a guy and put him back. I mean, nothing compared to what you guys had. But what I felt like in those cases, it was kind of like we're in a sim at this point. Yeah. Did it feel like that to you guys? Was it because it seemed like you could were you able to rely with the training, even though you didn't train for that episode? I would imagine your simulator training was helpful in that situation.
Well, no, it wasn't like a sim, because this cascade of sort of off-nominal things we had to do were spread over 3.5 days.
Yeah.
So it wasn't like a sim, which is a lot tighter timeline. Like, you might do a half a day of launches or a half a day of entries, so it was spread out. I was one funny thing, I kind of meant to be funny at the time. Jack Lausma was the Capcom, and I went for the first day and a half, or almost 2 days. The way we shifted in the LEM where we still could get rest. We hadn't got so cold. I was always on alone because I knew the LEM, the operating vehicle, well. Jim knew it, of course, but Jack had never, incidentally, Jack had never been in a lunar module, much like I had never been in a command module when I started training on 8. So he had never been in a LEM before in his life. So he didn't know much about it. So he and Jim were always on together, and I was on. And Jack Lausma sort of commented to me at one point. He just said, wow. He said, this is a heck of a sim. Yeah, I had to agree with him. Yeah.
Pretty amazing stuff that all you guys that you were able to pull all that off.
Yeah.
When this was happening, was it? I mean, you and Jack Swigert were, as you were saying, I guess, backing each other up, looking over each other's shoulders, reporting to the ground. That was, I'm assuming that's the way. What was that all like? Was it? You just, we got to get this done. What was your mindset thinking? What was going on at that point?
Well, that part of it, dealing in trouble early on after the explosion happened, the troubleshooting period of almost an hour to try to stop the leak in the second tank. That was, pretty much business as usual with what was going on with the troubleshooting the people on the ground did and asking us to do things on board now to try to isolate that leak. It was interesting. I complained to Ron Howard after I saw we had a pre-production show in Houston of the movie. And I complained, several things I complained about, but one was that he had the drama added in there.
Yeah.
I got space sickness early on from moving around too fast too soon. I wanted to get my task out of the way to have time to look out the window. And which I was told not to do. And I got space sickness and a little spit up. Movie, of course, had me throwing up a big vomit for effect. I had Jim Lovell hugging me. They had an argument I had with Jack Swigert did not happen. So those kind of things in there will bother me, a little drama that they took. And I complained to Ron Howard, and he said, I tell you, I listened to all the air-to-ground. NASA had given me, obviously, a lot of information, the mission report, and they gave me all the air-to-ground voices to listen to. He said, I listened to the whole mission. And he said, it never seemed to me you ever had a problem. So I figured I had to add some drama in there to humanize you, was his way of reasoning for that, anyway.
But with that, because I get asked a lot, Fred, like, what is the most accurate or depict, the most accurate of the space movies? And my answer is typically Apollo 13. Without that drama that was added, those conflicts didn't happen. I mean, I add that as well. But other than that, it seems. I mean, what is your comment about the movie? Let's go there, because you said, were you happy overall with the way it came out? Because it's it was. And I know you mentioned a few things that were, but what's your feeling of the movie?
No, it's still my favorite movie. Basically. But no, if you look at it from the big picture, I think clearly it carried the story of people in trouble, serious trouble, and a team that worked together, both on the ground and in flight ourselves, to do things that allowed us to get back safely. In that spirit, I'd say Apollo 13 has sort of morphed into what I would call a folk tale. It's a folk tale of a survival story, much like Shackleton, the crew that got trapped in Antarctica, and many of them didn't make it. But it's a story of that type. That's rather than a historical story like landing on the moon or going to the moon the first time. It carries a nice folk tale of survival. So I thought, in that sense, the movie did a great job. They said they added in some of these human things that didn't happen to make us seem more human and not quite as staccatic just reading procedures back and forth, or answering to Capcom. And they exaggerated the maneuvers. They showed one of the two mid courses we made manually, where they had the Earth in the window going up and down like we were about out of control. We made two maneuvers. They were very short maneuvers. One was just over 21 seconds, and one was like 18 point something seconds. One using the descent engine and LEM, one using that 4-jet RCS. If you looked at the data and the mission report, you would find that we did not even deviate 1 degree in axis, on any axis, pitch, roll, or yaw, because it was such a short time. In fact, with the descent engine, we had used it twice before. The first maneuver to get us back on a path to get back to Earth. So even on our flight, we were the first flight that went where we weren't on a path that would have taken us back to Earth. We weren't on a free return.
Right.
But we used a descent engine to make that burn first to get us around the moon, and then we made a second burn after passing the moon to get closer to a landing spot rather than the Indian Ocean. We got back to the Pacific. And so the engine had been used twice through the computer, fully automated.
Okay.
So that engine was pretty well steered through the center of gravity. It was a gimbal engine. So we probably could have not even touched the controls and for that short time, and it wouldn't have acted like the movie showed. So anyway, that was another sort of, you want to call it exaggeration. I also complained, but of course Ryan couldn't help that. The team that worked some of the problems was much bigger than Gene Kranz's white team. Mission control for all the missions had 4 teams, 4 mission control, 4 mission directors, 4 teams. And they obviously picked, because he thought Gene would make the best character for the movie. But behind that, behind the scenes, of course, in working some of these things, I mentioned Building 6 and crew systems people. Some of the contractors were consulted at North American, at Grumman. So a lot of people across the country where much of the brain trust existed, as the contractors actually designed and built the spacecraft. So NASA oversees that, manages the program, controls the budget and the schedule. But the real horsepower of the engineering skills and the design development are at the contractors. So some of that brain trust was called upon, consulting. And so the Kranz was your ascent flight director. Like in the shuttle, we had an ascent flight director, the ascent entry flight director and control team, and then he would hand it off to orbit teams, 3 orbit teams. Is that the way it worked for you guys on Apollo as well? It did. I know. I'm trying to remember now if Gene was going to be the landing director. Yeah, they switched off, and one team was kind of a floater. I think.
Okay.
One team was put in more for sleep periods, and call it the less dynamic phases. To relieve some of the other teams were having to handle more high energy, high adrenaline phases of the mission.
Similar to what we had. All right. So what happened? Was there a point where you felt like, okay, we're going to get out of this alive, or was it, was it just, what was the feeling? Was there like when the chutes opened, or did it not happen, or what was your thinking, or the relief, or what, after you did the procedure and you get into entry, what was that like?
Well, you had to honestly consider anybody that flew. Obviously, the point where you haven't made is when you can look out and see 3 main chutes. And you were going to splash down okay. Apollo 15 actually only got 2 out, but they splashed down okay. No, I was concerned about how the command module would work, because we had shut that vehicle down 4 days, had frozen. The water tanks in that vehicle, when they recovered the capsule on board the aircraft carrier, were found still frozen. So we obviously had abused all the electronics relative to
Yeah.
the specifications. So even though we got it powered back up, I was still thinking, I hope this stuff works, because we'd frozen it for 4 days. But it turned out Jack Swigert, who was operating through entry, left it in auto. He let the computer fly the entry. He was prepared, obviously, to take over if there was a deviation. But it gave us, if you look at the full-blown program report, a big, thick government document about that thick, and appendices list performance of various sorts, including entries, we tied for the second most accurate splashdown of the program.
How do you like that?
So, so that electronics came back to life and performed beautifully. Yeah.
So you saw those 3 mains and you said, okay, this might work out.
Yeah, we're home free now.
Before we move on, I just want to go back, if you don't mind, to the view you had of the moon. And very few people, you know, I get asked about what did the Earth look like and all that, yeah, because a lot of people have been to orbit now. You know, hundreds have been to orbit, but so few have been to the moon. And now we're going back. Hopefully, you know, we have a plan to go back with Artemis and so on. But, and I know you guys were in the middle of an emergency, but do you have, what's your recollections of your time at the moon? Because you did get a chance to take a look at this that not, you know, only a handful of people have. What was that? What was that like going around there? I know you were hoping to land, but what was that experience being there like?
People ask me about going to space, and I say there's 2 things. One, obviously, is zero gravity, being able to float around, float objects. But the second thing is views. And even spectacular are the views, even that you experienced in Earth orbit, and looking at our beautiful planet we live on. And when we went around the moon, we were coasting and didn't have to do the next major maneuver till after we passed the low point behind the backside at about a little over 130 miles altitude for 2 hours after we passed that point. So we had free time. So Jack Swigert and I had cameras out, black and white and color, shooting a lot of pictures, like tourists. And Jim, of course, wasn't interested. He had orbited a number of times on Apollo 8 before, and he was still like disappointed he wasn't going to get to land on the moon.
Yeah.
And but they're looking at the moon. It's just so obvious. The color, there's no coloration in comparison to the Earth, which is beautiful. Coloration, colors of seas, the cloud patterns you could even see from the moon. Big continental landforms, little halo around it that represents the thin atmosphere we have. And you look at the moon in contrast, it's just a beat up rock. I mean, the backside's even beat up more than the front side. The front side has big dark areas where major meteorites hit. The backside has a few of those, but it's mostly just crater after crater after crater. I see a scene shown right now at the backside, and that's almost everywhere. So it's been hit more on the backside than the front side. So it's just in comparison, just looking at it, you say this is not a very hospitable place to consider living. In comparison to Earth, and how same feeling I think they felt on 8 when they first saw it. We're so lucky to have the Earth, our home, to live on, because this rock next to us is not too good to think about a permanent home on.
Yeah, a beat up rock. Did you get, you know, we were talking about Bill Anders, who, my condolences, I know a good friend of yours, Fred, who passed recently, took that iconic picture of the Earthrise coming around. Did you guys get that view as well? Were you in that right attitude to be able to see that as well?
We did. It was a different Earth. When we flew, it was just before, I think, a half Earth. And by the 3 days going there, it would have crept on a little beyond the midpoint. So we had like a half moon.
Okay.
Yeah, which made it right for our sun angle at landing.
Okay.
For the site they had picked out for us to land.
All right. Cool. All right. So that amazing experience. Anything else you want to tell us about your view, either the moon or the Earth or the stars? When I know, again, you guys were working really hard, but is there anything else you can tell us about that? Because are you either going or coming of what sticks out?
No, I don't think so. Looking to the future, though, I
Mhm.
hope Artemis. My main concern is not technical as much,
Mhm.
although I'll have to say I've not worked at all with the Artemis program in depth, technically.
Mhm.
But they're facing, as we know, a real concern for any program is funding and
Mhm.
funding support, and they're of course facing getting through a presidential election and a new congressional cycle. So that's always a concern to keep the impetus on the program
Mhm.
and make it happen, is to have that support, which we
Mhm.
mentioned very early on was the great thing about Apollo. It had support. Funding was NASA requested was honored every year through Apollo 11.
Mhm.
And then the funding was started getting cut back some, but up through the landing, it was fully funded as prescribed for NASA. They had no hiccups.
Mhm. What are you excited about? What's coming up? I want to talk about moon. I also want to talk about shuttle, but let's hit the moon. What's coming up with Artemis? How do you feel about this? About us going back, and a lot of countries are landing now. The spacecraft, the number of countries have gone up the last couple. We got commercial organizations are trying to learn, working with NASA, trying to land stuff on the
Right.
moon. How do you feel about all this, and what's your advice or thoughts about us going back there? I'm pretty excited about it. Yeah, but
Right.
I'm wondering what are you thinking as one of the few that has been there?
Yeah, I'm excited in a sense that I hope they can affect their landings as they're proposing near the South Pole, where orbiting spacecraft have thought to have confirmed they've found standing water, ice, I guess, in some of the areas near the South Pole that never see sunlight, in depressions, or I guess in craters that never see the sunlight. They've actually have ice garnered, which obviously would be very good. It breaks into oxygen and hydrogen, which is good for propellant. It's good for life support. Thinking maybe a little longer term of a lunar base established. And of course, that gets into another degree of support to make that happen with the logistics requirement to both set up a base and then operate it as we do. We humans do on Antarctica. We have about 3 different countries have bases that operate year round at Antarctica. In a similar way, need a certain logistic support to continue to be operational.
Are you surprised it's taken this long to get to this point, Fred? You know, I get asked that question a lot. You know, when my astronaut class started in 1996, which was 28 years ago now.
Yeah.
You know, we were hoping one of us might be going to the moon, and that was 28 years ago. But it looks like now, you know, now we have a crew assigned to at least orbit the moon.
Right.
Are you surprised it's taking this long? Or do you think it's about right? How do you feel about that?
Well, I mean, considering coming off Apollo, yes, I thought we'd march right on.
Yeah.
But no, I just looking at the way the world works and world affairs and how our U.S. government has to react. Yeah, the support that I'd hoped would be there, or many people hoped would be there, it's been diverted somewhat by wars we've been in. Vietnam war was very expensive. Iraq, Afghanistan, so on and on. That's kind of garnered the attention and also funding requirements that have made the space program in the interest of going back to the moon lesser. And the mentality of you know, Congress and wanting to address that with more funding has been lessened, no question.
Yeah, I'm glad it looks like we are going to get people back there, and as you say, settle and try to live there for a while. What's your feeling beyond that, going to Mars? What's your feeling about sending people there?
Well, I know even less about Mars, except it takes a long time to get there. It's not a mission I frankly would like to take because of that length of time. And you know, not a good view most of the way. The Earth will disappear shortly and not be a good scene, and Mars will be farther away for a while, and it won't be good to see. And then it's so much is automated these days. So the piloting role has been taken away. You know, Dragon has, I think, one control and abort. That's all you can do. And so as a test pilot and pilot primarily in my background and interest, there'll probably be some capability for landing, just as there will be for going back to the moon. Because whatever site you pick, either on the moon near the South Pole or on Mars, there will be a lack of definition down to the point where, and that's what caused all of 6 landings we made to be manually done, was where the computer had been picked based on the photography available, the definition was not suitable. So they had to move the vehicle somewhat to affect a safe landing place. So I think the one thing you get for all that long journey, you may get to land the vehicle. But that's the only piloting involved. In fact, we're seeing that with some of the unmanned vehicles recently that have tried to land on the moon. One ended up toppling upside down and one on its side. For the same reason, they had a spot picked that wasn't as suitable as they would have liked to touch down on, with boulders that are below the definition of anything they could see on orbit.
It's so it's a lot of, again, a lot of, it sounds like the impression I'm getting here, Fred, was a lot of simulator flying but the real flying you would do could be quite sporty,
right?
For preparing you for that for the landing on the moon, for example, and what we might be seeing moving forward too. And the other thing, Fred, I think this kind of leads into the Space Shuttle and your career. I mean, after the Apollo missions were over, you worked on the Space Shuttle program quite intimately, and one of the few pilots that got to fly Enterprise, which is the spaceship on display at the Intrepid Museum. Where did that fall in the category of your preparation and actually flying that vehicle on the landing tests from the test pilot perspective?
Well, my involvement with shuttle, and actually it set me up for my next career I had in industry. See, I left the astronaut office and went to work in the orbiter project office for 4 years. So I worked on the team that evaluated the proposals contractors submitted to pick who would build shuttle, Rockwell. And then I was in the orbiter project office for 4 years. Through all, I led an ops team through all the design reviews, through a critical design review for Enterprise, and through a preliminary design review for Columbia, the first one to go to orbit. I sat on the engineering board that evaluated every engineering change made on the design throughout the program up to that point when I left to fortunately be named as one of the 2 crews that would get to fly Enterprise. First flight we're going to make of an orbiter, launching off the top of a 747 aircraft. So that was back to Edwards for me. That was an aircraft test program. So I was back to Edwards doing what I love to do. So I look at that build up through the program office through to getting to fly the vehicle the first time. Probably the greatest experience of my career.
Wow.
But at the same time, it gave me all that program office experience of learning about budgeting, learning about the congressional process for budgets every year, and the engineering design development with the engineering board experience. That made me good to now move off to industry later and have a 17-year career in with aerospace business.
That's really saying something, saying that was a highlight for you. And I kind of got the sense, of course, I was a civilian, not a test pilot, professional pilot, but of course I flew with my commander and pilot on my missions, who had many. They had a lot of experience flying, and they really love flying the shuttle. It was just that one landing you get to do, but thousands of practice dives in the shuttle training aircraft and simulations leading up to that. But really, the talent behind you and your colleagues who were the astronaut pilots who flew that space shuttle was amazing. The coolness that the skill required to do that is very rare, and yeah, quite amazing to see it firsthand. You have my admiration for what all of you were able to do with the space shuttle.
Now, it was obviously in some ways more complicated than Apollo. The thermal protection system with the tiles was a much more difficult challenge. The main engines, high pressure engines, the SSME development for shuttle, much more difficult than, I'll call it, the low pressure. First stage, Saturn was kerosene and LOX, and upper stage is hydrogen, oxygen, but low pressure engines, much less risk. And control system, the entry control system was very, very complex. Whereas a capsule, if you managed to get the blunt in first, it was locked into the atmosphere when you entered. So you really only control roll. So you had rolls to control the effect left, right, and up or down range with the offset center of gravity of a little capsule. Whereas that orbiter control system went through about 3 different modes to get through entry from Mach 18 down to the ground. So it was a much more difficult control system design, challenging.
And you had to land on a runway.
And you had to land on a runway, so energy control was obviously much more critical. Yeah,
going quite fast still, hitting that amazing what it was able to do. With that, we started talking about test flying and some of the comments from Neil Armstrong and about the astronaut job back then maybe not being as much flying job necessarily as a test pilot job. I want to make sure I got that accurate. So correct me if I said anything incorrect there. But when we get to the shuttle, was it more, again, what you were accustomed to? You said it was like going back to Edwards and so on. Was that more of like a test pilot flying job at that point? When
it was, particularly through design development and the simulations that were done to, again, perfect the handling the vehicle and the way it would fly in over such a Mach regime. So the X-15, for instance, the fastest it ever got to, it's still a record considered for an airplane kind of vehicle, 6.7 Mach. So it went instantly on that first flight, which was a great risk. Only flight we've ever flown manned. First flight of shuttle with Cripp and John Young, Bob Crippen and John Young. It's the only first flight we've ever flown with humans aboard. And they instantly went to Mach 18 to get in the Earth orbit. And had to re-enter from that. So that was a big, giant leap in shuttle.
I got the sense of it with my test pilot colleagues that they really loved that job. They loved the vehicle and flying it and learning how to fly it and all the systems. And the talent that they exhibited and being able to do that successfully was quite impressive. I feel very lucky. I got a firsthand seat to see what was going on there, and amazing what they were able to accomplish. I think I know we're a little bit past 4 o'clock here, Fred, and I want to thank you for this time. And we got some more time left, and your connection with Intrepid Museum, with Enterprise, and also they have this new Apollo exhibit there going on. So it's really very fortunate to have you here this afternoon. But I want to share you a little bit with the audience if there's any questions coming in.
Sure, that's fine.
See what they have for you. John, is this a good time to try to look at some of those?
Yeah, absolutely. We've got quite a bit of, honestly, the biggest thing we have in chat is people saying thank you for the stories. Like, this is direct access to your memories, Fred, and the majority of what is coming through the viewers right now are people just saying thank you for taking time out of your schedule to spend with us. So,
all right, I'm happy to do it. I really am.
Let's see here. There was a specific question that came through about some Sony tape recorders or some tape players that you had on Apollo 13. Do you remember, did you have any favorite song or tape that you listened to when you had any sort of downtime or ability to relax or chill out, assuming you had time to do that, right? Did you have a favorite tape with you?
Yeah, we had a suite of music, I think the only one that really got into listening to some of it or understanding what was actually being put on by someone else onto a tape recorder for us to listen to.
Yep.
I had nothing to do with it. I never listened to it till we were in flight. And so I don't recall if it even had one of the prominent songs played in the movie that supposedly was on it. Can't acknowledge whether that was there or not. Worrying about the music we're going to listen to was not foremost in my mind at the time getting ready to go fly.
Fair enough.
The same way the patch. It was interesting. People asked me about the patch. I had nothing to do with our patch, which has turned out to be, I thought, well done. Jim Lovell actually did get in that and employed the interest and help of a New York artist to help with that design. So, but I had nothing to do with the patch either.
Wow.
Gotcha. I'm just going to go through again. I read through the things. This is a great show. Fred, you're just as sharp as you were on the mission itself. They love listening to your perspective. Here's a great one, actually, from 1960 ALP. Did the simulations change based on the experiences of Apollo 13? Mike was asking you the great questions about, did the previous sims teach you anything you used on 13? Of course they did, but did they change the sims for the future going forwards?
No, I went. Obviously, I went through one more cycle. I was a backup commander on Apollo 16. I don't recall that we did anything different. They may have exercised more, a couple of runs where you did the manual maneuvers, as we did without the computer, because that's about the only thing that we did unusual that way that might be employed in some way. Some lunar aborts would use that requirement. For instance, if you were going and some sims earlier were done, but the command module fully powered up. What caused those was where you were going into lunar orbit, and the SPS engine that was trying to slow you down to go into orbit failed. If it failed, you now didn't want to stay partially in the lunar orbit. So you had a quick startup of the lunar module and a burn of the lunar module to assure you didn't go into orbit, that you would now just leave the moon and head back to Earth right then.
Right.
So there were some sims, a couple of them that covered that particular situation that required using the manual method of control of the vehicles.
Gotcha. I'm just going to keep going through with some questions here. Mike, if you have a question you want to hop in with, just hop right in. But I think this one, there's a balance we've heard here, right? There's sort of the steely-eyed missile men, your description of how you were during the mission, and then the movie portrayal of how it was sort of embellished and livened up a little bit or something like that. How did you react when you went to stir the tanks and there's this problem that's occurred? We've got a problem here, right? How did you feel at that time? And was that captured in the movie, or was it not really, or was it embellished too much in the movie?
Well, I don't know how they would have captured it, but at the time of the explosion, it was interesting. We had just finished a live TV show. So if the explosion had happened 30 minutes earlier, we would have been on live TV when it happened. So I was still in a limb by myself, and Jim was just leaving to head back up, drift up through the tunnel to get back to the command module when this happened. I was putting away equipment we had pulled out to talk about. We had planned to talk about during this TV show, kind of a show and tell. And the bang happened. A lot of firings of the small 100-pound thrusters trying to hold attitude, which was unusual. And pretty quick, I drifted also behind Jim to get back in the capsule. And when I got in the right couch position where I had in front of me all the cryogenics, the fuel cells, electrical system, some of the environmental communications. The scan of the panel quickly was first confusion. because we had like 6 or 7 caution warning lights on, which made no sense because, as I said, our little computer, unlike your automobile today or current spacecraft, everything is wound through links through a computer, a centralized computer to control things. Our computer did very little, and all our systems, what I call standalone. In other words, they were separately wired to separate switches and controls that we did manually, like turning fans or pumps on and off, or opening and closing valves. And the lights covered different systems. So there's no way one system and one would cause the lights in other systems to light up. So that was the initial confusion. As it turned out, some were real. Some of the 2 fuel cells we lost immediately from the G-shock of the explosion, which closed reactant valves. So they shut 2 fuel cells of the 3 down. But quickly, Mission Control got into it. But beyond that, let me just say the other observation I made was looking at the cryogenics, 2 readings on tank 2, oxygen tank 2, were down in the bottom of the meter. So I knew there were 2 different kind of sensors. I knew we had lost tank 2. So my feeling then went just almost sick to my stomach with disappointment, because I knew in that instant, this is probably after I arrived back on the couch within 2 minutes, I knew we had lost the landing mission. We weren't going to land. That was an abort. Probably wouldn't even go into lunar orbit. Wouldn't go into lunar orbit. So I was just sick with disappointment. I didn't think it was life-threatening because tank 1 looked fine. And quickly, the Mission Control, which had telemetry to those valves that had various gaseous and liquid valves, had been rocked closed by the G-shock of the explosion. We couldn't see that on our panel. We had little bitty square things that were either gray if the valve was open or bobber pole if it was closed. For us, they were only connected to the switch, a toggle switch. So we couldn't see where the valve was. Mission Control had telemetry, and they had us recycle those toggle switches for those valves that had been closed inadvertently by the explosion back to open, and many of those lights went away. They were kind of false warning lights, so to speak. So we not only had to deal with the electrical problem, and now what quickly came about, and Mission Control saw that first, was a slow leak in the oxygen tank, tank 1. So that's when I said we spent the next hour with Mission Control trying to figure out ways to isolate the leak, where the leak may come from, to try to isolate it. Just about the first hour. And that's when they run out of ideas and asked Jim Lovell and I to get to the landing craft, the lunar module, to start a power up, because they knew we were going to lose the capsule. We have to shut it down.
Yep. I want to repeat something you just said. It shows like the dedication and the drive of the folks like yourself who were put on these missions. When the bang happened, you called it the bang. It wasn't, oh, my life's in danger, I'm scared. It's disappointment that the landing mission's off. Like you said, you knew that the landing was off.
Yeah, because I'm saying the circumstances were, if tank 1 had not leaked, we would have just stayed fully powered up and done an abort, a maneuver of some kind that had us back to Earth.
Yep.
And come home. So it really, in that short time, it didn't become apparent this was really as big a problem as it was.
Yeah. And that comes back into, we have the photos of the CSM, right?
All right.
But you couldn't see this at the time. When it occurred, this wasn't a view that you could look out the window and say, oh yeah, that doesn't look too good. This was
now, out the window, I could see, looking out my window, a sea of debris. Because when that tank let go, I guess the oxygen froze into particles, which close aboard you could see were ice crystal-like. A little ways away, they look just like stars. And you could see some of the torn thermal blanket. The gold and silver material had been shredded when that the quarter panel blew off. And that was floating outside. So but we couldn't see that area as I'm now looking at the picture.
Yep.
Of the quarter where it blew off that one quarter panel with both the hydrogen and oxygen tanks laid and fuel cells.
I think a lot of people don't understand when you're in a spacecraft, it's not like Kerbal Space Program where you get to see the outside of your spacecraft from all angles. You're sort of inside of it, and the only view you have is outside your window. And Mike, I know you've done the same with Shuttle, where they got into the inspection arm to look at parts of the spacecraft you can't see. But I think a lot of people don't understand it's not like a video game. You're inside looking out.
No, they can. Now they have what we call the bird's eye view. Even when I was back at NASA, 10 years ago, we had a bird's eye view of things that could simulate what you would see. And it was mainly helpful for things like during the rendezvous or robotics. So you can have a camera that doesn't exist, a simulated view.
Gotcha.
And so that, we have that computing power now to do that. But I don't know how you would simulate what that would look like. Certainly you have a capability now to inspect the spacecraft and have different views of it. That would be helpful, but Fred and his crew didn't have anything like that.
Yeah,
so
a light blinking on a panel somewhere.
Yeah, were you in total shock when you saw that, Fred, or did you expect something like that? Were you just not knowing what to expect when you finally got a view of it?
No, it was a shock. No, I had not expected to see that much damage. And it was interesting. There was a shadow look on one side of the bell on the SPS engine. So it's probably wise they did not choose to try to use that engine. Even within that brief time the command module was active, because I'm not sure that would have been good. Probably had damage. Yeah. So they made the right move to just rely on a limb to take the longer way home.
Yeah.
Yeah.
You mentioned the inspection part, John. We didn't have that when we lost Columbia. When we lost that space shuttle, they didn't have the full inspection capability.
Yep.
And so they don't know. They had no idea that there was a hole in the wing. That was determined afterwards through the investigation of what actually happened to that wing. So, yeah, after the Columbia accident, it changed things for the space shuttle. We inspected everything at the beginning of the mission to see if we got any damage during ascent, and at the end of the mission as well to see if we got any damage during our time on orbit to make sure we could come home safely. So
and I guess even where you went to space station, there were shots taken where you were close to the space station. Right?
Yep, you got up to the space, you do a flip maneuver, which was the acronym. It was a spin to take the high def photography from the space station. And we didn't have. I was at Hubble. We didn't have the ability to get that from station, but so we had even more inspections to do with the arm. We had a boom on the end of the arm. We call it the inspection boom.
Right.
But that changed things because they didn't know they had a hole in their wing, and so being able to see your vehicle is pretty important.
Yep.
Particularly before you come home.
Before you come home,
make sure it's okay. Yeah.
We say space is hard, but it's hard for a lot of reasons. It's not just the physics or the engineering that's involved. It's some practical matters like that. Like, how do you see the outside of your spaceship? It seems simple, right? Fred, we've got so many good questions coming in now that we're sort of answering questions, but I think this one is important to sort of relate to for a lot of people. You went through a very surprising, traumatic experience where you're up there, you're going around the moon. Did you feel doubt or did you feel anxiety when you were in that situation, and how did you deal with that?
Well, obviously I was apprehensive in this particular case because of the degree of the problem, but it's something mentally, at least, I dealt with before I ever flew. Sort of when I was in squadrons, if I was in 2 fighter squadrons, you had a similar concern there. In 2 years in one squadron, we lost 6 pilots. So we always had a designee appointed, a friend in the squadron that was going to be the one that would take care of your family. Designated mainly handle administrative because they obviously the family, other pilots, other wives would be there to help as well. And similarly, before I flew Apollo 13, Jerry Carr was a neighbor of mine. Jerry ended up flying the last Skylab mission, the longest mission that was flown. But I asked Jerry over and showed him where paperwork was and stuff. And he was going to be my designee if I didn't get back off Apollo 13. That would take care of things as best he could for the wife and family, and then the arrangements and administrative type things that had to be handled. And like I said, there would always be lots of other astronauts and astronaut wives that would join in as well to support. So that's kind of normal practice that was done because that you had the possibility on any of these that something may happen.
Yep. It's no stranger to tough situations like that coming up through test pilots at Edwards and all that sort of stuff. It's a reality that the way we used to test things a lot of the times was strapping human beings to them,
right,
and seeing how it works.
And that still goes to this day. That's a serious, that's before you fly. We have the system is there for where the paperwork is, where everything is, and yep. All that is still in place. I think that came in from, as Fred described, what they went through test flying years ago. That's still the way it's done now.
Yep.
At NASA in the astronaut office.
I want to bring this up real quick because some people were asking a little bit about the photos and stuff I've been showing, and sometimes we like to keep the show really clean and we download all these photos, then we just show them. Look at this produced show, right? Mm-hmm. But Fred, your website is so fantastic. FredHaise.space. I've just been clicking through and intentionally showing that I was clicking on your website because there's so much to explore here. I scroll all the way up to the top. There's all sorts of different parts. You've got the career paths, the NASA research pilot, astronaut adventures, the rocking chair years as well. But folks that are watching, you really need to go to Fred's website. There's so much material here. There's logs in your original handwriting. I guess not that you have unoriginal handwriting, but you know what I mean.
Interestingly, that I have, like that 1 year at Grumman, I have almost a daily diary, handwritten. I had handwritten notes to the project manager on Orbiter when I was in the project office. I have a teacher that's a Space Hipster.
Okay.
On a Space Hipster Facebook's one of those 60,000 members now. Space Hipsters has 60,000 members on Facebook that are space fans. Some worked in the program. And she has offered and is now converting that handwritten stuff to a PDF. She's having trouble with the acronyms, which I help her with, and things like that. And realizing that younger children now, unfortunately, I think, in some schools are not being taught handwriting.
Yep.
And so they'll need to trigger now under that handwritten portion and the archival data, they read it as a PDF. For instance, also in the archival data is the published, digitized now, accident report for Apollo 13.
Right.
So if you want the real accident board's evaluation and their written report, published report of that accident on Apollo 13, you'd find it there. I have two NASA technical notes in there that are digitized. To read. One is on the Zero-G program. Jack Enders and I, a fellow test pilot at Lewis Research Center, we had the second Zero-G program in the country. The Air Force had the first at Wright-Patterson, testing human subjects. We had a AJ-2 aircraft, Bombay, we used to test fluid systems, including developing, for instance, the tank, screens in the tankage for the Centaur rocket that's still flying today, cooling system for the SNAP-8 nuclear power generator that flew to space for satellite systems. Now, we didn't have a nuclear core. We used a carbon heater to emulate the nuclear core in our Bombay, but we did those kind of experiments with that aircraft.
No kidding.
Second technical note is evaluation of 7 general aviation aircraft, complete stability and control, handling qualities evaluation. I did that was the last program I ran as a #1 pilot at Edwards before I joined the astronaut program.
Fred, you're sitting here rattling off all the details of the documents and stuff on the website. It's amazing. I cannot say enough, folks. Go to Fred's website. click around and look at all the different things. I was intentionally showing you that there's this just treasure trove of information on the website, photos to click through. It's all so well organized and labeled. Like, you click on a photo and it says who's in the photo and when it was and where, and you can download it. It really is a lot of work has gone into this, so I want people to go and check this out. How are we doing on time? We got just a couple minutes left here. So I had a question that sort of both of you was relevant to both of you. You both have done so many different things in your lives and all the different training, all the different experience you've gone through, but the conversation always gravitates sort of towards this one event, right? Fred, you're Apollo 13. Mike, you're up there with Hubble. Is that good? Does that make you feel like, all right, that's the way that went? Or are you disappointed sometimes that all of the other amazing things you have done don't get as much limelight, attention, focus? Like, Fred, how does Apollo 13 defining so much of what you've done, how does that sit with you?
Well, yeah, it's one event, 6 days of my life. So it's not the life. Probably from a traumatic standpoint, the most serious thing I suffered in aviation was I crashed an airplane and suffered burns over 65%, and spent 3 months in a hospital, about half of that grafted, and took 14 months to get back to flight status. And that was between Apollo 13 and when I flew shuttle. So I worked to get back to flying. So that was a kind of an incredible experience to go through, to be in that burn ward for 3 months. And University of Texas Hospital at Galveston. And of course, I made sure they didn't know I went to the University of Oklahoma.
Want to keep the standard of care up.
That was a very emotional, because initially I thought my career was ended, my flying career.
Yep.
And so that was obviously one point that was very deep in that sense. The first flight of Enterprise was another great event, like I said, from a flying career standpoint, a highlight. And the concern I had in approaching that flight, not my risk, but concern about the 747 crew. There were 4 people aboard. The first time we're going to really see how the primary flight control worked, which we had through engineering simulation, had highly tuned it to be a pilot rating of 1 or 2, which meant it was, could be on the threshold of instability. Where when the first time we'd get to see how it really worked was when we separated, and you didn't know when flight control goes unstable like that, you could have ailerons flailing around, completely out of control. Now I had a backup plan B initially, one switch on my stick I could push. It would cut off the input-outputs to 4 computers and switch to the 5th computer, which was a much simpler flight control system, sloppier, by the pilot rating of 4 versus a 1 or 2 for the primary. And I knew I could get it on the ground. So that was the backup. But I really worried about that point of the vehicle going out of control. If we had hit the 747 tail, that 4 people would have been lost.
Yep.
And I had a plan C, actually. I had a plan C, was an ejection seat I was sitting in. So Gordo Fullerton and I were, I felt reasonably, from a risk standpoint, we were in much better shape than the 747 crew at the time.
All right. There's so much more, like now everybody in chat is saying that we wish we had more time here. We have come up to our 90-minute show here, but there's so much to learn, not only just from your website, Fred, but your book as well, the Never Panic Early. I almost brought that up earlier so I could say, never panic early. But we've been putting links to chat over there, so if you're interested in learning more about Fred's life and experiences beyond Apollo 13, you've got the book and you've got the website there. So please, if you're watching right now and you're fascinated by it. Like, who even knew? How many folks that are viewing right now knew that Fred was in a plane crash after Apollo 13 and had the recovery to go through, right? If you really want to learn that stuff, there's so many resources for you. So check out the book, check out the website. It really is fantastic. Mike, I'll leave it with you for a little outro here if you want. And
sure. I want to give Fred the last word, but
Yep.
I do want to say thank you, Fred. It's been a real honor to get to know you and to get to spend this time with you. I don't know if you remember, we first met in the lunchroom at Falcon Pass Elementary School, where I was there with my son, who was a kindergartner, or maybe he was in second grade or something, and you were there with one of your grandkids having lunch, and I saw you across the table. You could go and have lunch with them. Do you remember this, Fred?
What school was that?
Falcon Pass Elementary. I'm going back, I'm going back 20 some years now, right? When I was a new astronaut, and I'm sitting next to my son. I go, Dan, you're never going to believe who's across the table from us. And we said hi to you, and you were very nice to say hi to us. And but you've been a hero of mine for a long time, and to get a chance to do this with you today is surreal. And I want to thank you for your time, and also for what you're doing now. As John said about being known for certain things in Apollo 13 or whatever it might be. I think you've done an unbelievable job of taking that experience and applying it in industry. You said in your aerospace career, but also now, and all you're doing for education and to inspire in that website and your book. So I just want to say thanks to John and the Intrepid Museum, but mainly to Fred for spending some time this afternoon. And I'll let Fred have the last word there.
Well, I just want to thanks to you, Mike, for supporting Intrepid, a great museum. I do the same. I've been involved 18 years directly. I'm board of directors of Infinity Science Center, which I started on the board from scratch. And the initial challenge was to raise $40 million to build it. So we were starting from grounds up, but now running and operating. But mainly to the interest for me was in doing that, getting out of my rocking chair after I retired, was I think museums provide a spark, potential spark to children that see great things that have been done in aviation and in space that may trigger them to make the best use of the talent they've been born and blessed with. We all are born with some talent, and a big challenge in life is to figure out how to best apply it. And if you can do that, of course, you'll generally be more successful in what you take on and what challenges there are, and you'll be happier through, not that life is all happiness. Everybody has to deal with some ups and downs, but overall, you'll have a much better life if you can find a way to apply that. I'm not doing it just to make everybody an astronaut or even an engineer, but maybe trigger them to just figure out what they do best and to make the best use of that. So it's a great thing to be involved in. In fact, tonight I'll be at a dinner with teachers tonight, mainly science and math teachers coming in for a big convention at Johnson Space Center this coming week for a conference. So I do a lot of those things, and also Zooms with schools around the country in a similar way that hopefully I provide a little influence, a little trigger to maybe make them make the most of their lives ahead.
Outstanding. Folks, I say give a round of applause, right? I guess we don't really give rounds of applause in the text chat over there, but Fred, thank you so much for your time this Sunday. Mike, always a pleasure hanging out with you as well. Little bit of housekeeping, folks. This was Astro Live today. You know, we do these shows just about every month. Sometimes they're virtual, like today's show was. Yeah, that's the right way to say that. And sometimes they're on site. So we do have an event coming up next month as well. That one's going to be on site. Just a second, I'll tell you about that. I want everybody to remember these shows don't just magically happen out of nowhere. It does take a little bit of time, and it takes a little bit of funding to make them happen. Astro Live, supported through a NASA cooperative agreement awarded to the New York Space Grant Consortium. You've heard me say that before, but that's why we can continue to provide this sort of access to you. And also, remember, the exhibit that's out at Intrepid, Apollo, when we went to the moon, is still out there through September 2nd. There's actually a discount code right there on the screen, Apollo PROG, to get a little bit of a discount if you can go to Intrepid and see some of that hardware up close. We had like gloves in the lunar rover mock-up that they have, and all the different pieces are there at Intrepid Museum, but only through September 2nd. So if you make it out there, please make sure that you check out Intrepid Museum. Also, coming up this week, this Friday, there is a Free Friday at the museum. It's actually a movie on the flight deck, and who can guess what movie is going to be shown at the Free Friday out at the museum this week? It's Apollo 13. You should have been able to guess that. That's the movie, Apollo 13. The museum's going to be open for free from the hours 5 till 9 p.m., so you can come out there, see some of the exhibits, and hang out on the flight deck to see Fred's movie, Apollo 13. Let's see here. Oh, next month as well, we have a show coming up. There's just too much cool stuff going on. Let's display that. It's Astronomy Night on site at the museum, Friday, July 26th. I'll be out there as well, but so will Charlie Blackwell Thompson, launch director for the Artemis program. I had to lean out of the way because the image was cropped a little bit there. But that's going to be happening next month at the museum. ASL interpretation will be available for that show. And, of course, we'll be sharing it with you live. I saw a couple folks coming through supporting what we do directly with some fundraising, I guess, today. So thank you all as well for making it so we can continue doing this. But for now, that is going to wrap up our show for today. Again, I'm going to hop back this way one more time. Fred and Mike, thank you so much for your time today. It's always a pleasure to hear stories and get those experiences. This is the part where we can all wave, and we will see y'all later. Thanks so much for watching Intrepid Astro Live, y'all.
Bye-bye.
Thanks, John. Good job.
Good
Take
day,
care.
Fred.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, Atlantic.
Water towers fly! Yes! Tango down to nominal.
Flight downside FTE off. Bring in FTE off. Off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane would be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.